Greetings and welcome, friends. Mr. Watty here. We're talking about section 6.6, Inequalities within dos triangles. Imagine a gate between fence posts A and B. All right, guys, are you imagining this? I really need you to imagine this right now. That has hinges at A and swings open at B. Oh, here we go. Here's like a top-down view of this gate. I like it. Right, Isaiah, you with me? Are you imagining?
I'm with you.
I wish I could reference like 3 seconds. Someone take this video and edit in the part where SpongeBob was all like imagination, and then that'd be great. All right, as the gate swings open, you can think of it as triangle ABC with side AC being formed by the gate itself. All right, so here's a sketch of said gate. All right. Side AB representing the distance between the fence posts, right, Malik? Yeah. And side BC as being the opening between the fence post and the edge of the gate. Notice that as the gate opens wider, both the measure of angle A, so this angle here, all right, let's see, I'll label it with this color. This angle is no longer congruent to itself, right? This angle is getting bigger, perhaps, and the distance of BC, do you think that when you open a door, it gets wider, guys?
Does the door itself get wider?
No, but like the opening, the distance from the fence post.
Oh, it's all the same. I don't have fence posts next to my room.
All right. Well, it would get wider. So here we go. Let me open up a Theorem's sketchpad sketch. So notice I've got two triangles that the blue sides are congruent, the green sides are congruent, and I can have them at varying angles. So notice here we go. Whoa. All right. So those blue sides are always congruent, the green sides are always congruent, and I can have them at different angles. All right. So when I swing this around, this is always going to be the same distances, but have different angles. All right, let's see what happens to these orange segments. Let's see, measure and lengths. There we go. So even though the blue segment is still congruent and the green segment is still congruent, when I move this, notice the wider that it gets, the wider this angle right here gets, the longer the orange segment becomes, and that the smaller it gets, the smaller the orange segment becomes. Even though both the green line and the blue line are maintaining their congruence. Let's measure these angles. Actually, I'll measure this one first, and then that one as well. Measure. Oh man, guys. I guess I can't do that. Anthony, you can go back to your seat though. Let's see. So there's one angle. Let's measure this angle. All right. So notice that, right, as this angle CFD gets smaller, the side length CD gets smaller as well, even though I'm dealing with consistent side lengths for two of those sides. All right, so that's kind of what we're talking about. Makes sense? Here, let me sign something here. I know. I mean, with all the views I have on YouTube, you'd be surprised. The paparazzi is always hunting me down, and people just want my. That is why I always have the shades closed. Also, so that way I don't get assassinated by the government run by Pythagoras when I teach you about the square root of 2. I've told you that story, right?
Yeah.
Yeah, Pythagoras and the square root of 2 and irrational numbers. Well, that'll be a story for someday. So guys, check this out. The Hinge Theorem. If two sides of one triangle, all right, bing, 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 are congruent to two sides of another triangle, all right, and the included angle of the first triangle is larger than the included angle of the second, all right, so larger, then the third side of the first this side, okay, is longer than the third side of the second. All right, hinge theorem. Makes sense. Like if I'm pivoting amongst this hinge and these two are fixed lengths, I can make a triangle whose, right, this side opposite of that angle is going to get larger or smaller as I shift those around. And it turns out that the converse of the hinge theorem is also true. If two sides of one triangle are congruent to two sides of another triangle, and the third side, so this time I'm starting with the sides, right? Starting with the sides is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So this angle is going to be bigger than that angle. All right, so that's the converse of the hinge theorem. Not too shabby, right? Yeah, you think it makes sense? It's the hingiest. All right, let's see if I can do example 1 with you guys. All right, hinge theorem. Oh, so here we're actually going to use the converse first. That's fine. Given that ST is congruent to PR. All right, yeah, I see that. How does the measure of angle PST compare to the measure of SPR? All right, what else do I know about this sketch?
Yeah.
All right, so PS is congruent to itself. All right, that's true by reflexive property. Right. And let's see, angle PST is this angle here, and I'm relating it to this angle SPR here. Are those going to be the same angles? No, they are not. They are not. If those were parallel, then we'd say they must have been, but we don't know that. But what I do know is this length here and this length here. All right, notice that PT is bigger than RS, right? I'll just say given, kind of, or just like, I don't know, compare the numbers because of numbers. All right, so what do you think you could tell me about those angles? And why is that true? Because of the converse of the hinge theorem. Right? Yeah, not too shabby. Okay, not too bad, I don't think. Let's see, here we go. Because it's opposite of a larger side. So PST is going to be the bigger one. Thoughts? I'm holding it. Wait, that's not what you gave me. So,
that's like completely different from this.
What thing? Well, this is in two separate triangles. Are you talking about the triangle inequality theorem? Because these are two different triangles. Right. That works within a single triangle. These are two separate triangles. Yeah. All right, let's see. Given that JK is congruent to LK, how does JM compare to LM? All right, oh, I've got different angle measures. All right, so I'd have like my given information or whatever, right? I'm going to say that the measure of angle JKM, I guess I should do capital K here, is bigger than the measure of angle LKM. Right, that's given. Right, this angle is bigger than that angle. So what do you think will be true about these side lengths? Oh wait, I also need one more fact. Reflexive.
JM is bigger than.
Right. and reflexive. And so you are arguing that JM is going to be larger than LM. And why is that true? HT, Hinge theorem, not HL. You're thinking hypotenuse, leg. Yeah, the HLT, which is like a ham, lettuce, tomato. Maybe. The mediumist ham, lettuce, tomato. Okay, so that's not that bad. Guys, let's talk about why, we'll just talk briefly about the converse of the Hinge theorem and how I might be able to prove that true. Let's see, let's take a look at example 3. All right, so we start with the given information, okay? So we start with this given information, and I'm told that AC is bigger than the DF here. They want me to prove that angle B is going to be bigger than angle E. All right, so let's see what we can do. I think we're going to have to do proof by contradiction. So I'm trying to prove this. So let's assume that what I'm trying to prove is false. So assume, question?
Would we assume that if E is less than E, or would we assume that E is not greater?
Is not greater,
Okay.
which is slightly different. Slightly different. So I'm going to assume that the measure of angle B is not greater than the measure of angle E. All right? The reason is I'm assuming that. All right? So that puts me in 2 cases. Well, actually, let me first highlight this. All right, this is I'm pretending this is true, but I don't really believe it. All right? So let's consider case 1. All right, case 1, that means it could be less than it. Right? That means the measure of angle B could be less than, man, yikes, less than the measure of angle E. Okay? And if this is true, then if this angle is less than this angle, then what would I know about the sides here? Assuming the Hinge theorem is true, I would have that AC is less than DF by the Hinge theorem, right? Can that be true? No, that's my Metal Gear Soldier, right? Exclamation point. All right, yes, I'm pumped. I'm pumped. So this cannot be true. It's impossible. All right, let's consider another case. All right. What if
Wait, what is HP?
Hinge theorem? Hinge theorem, yeah.
What is that one?
Because I already said that it was given that it was actually the opposite of that.
Okay.
Kind of.
Okay.
All right. So it's possible that maybe angle B was less than it if it wasn't greater, but it's also maybe the measure of angle B is equal, would be the second case. If it's not greater, it could be equal. Okay? And if these angles are equal, then what would be true? That will be what I conclude, but first I'd have to say what? By side angle side. And then what Josh just said, that AC would be congruent to DF, and then AC will equal DF by def of Kong. Right, def of Kong, or CPCTC, and def Kong. Right. And that can't be true because I just said that it was greater. What?
Why do you have to do this when it's different?
All right, that's impossible based on my assumption. So since both of these cannot be true, they disprove one of my given statements. If I assumed this was false, the only conclusion could be that this is true.
Make another case.
No, so that means therefore the measure of angle B is greater than the measure of angle E because of proof by contradiction, right? There's no other possibility, right? I even pretended for a minute that it was true, and then, right, that the opposite was true, and then I couldn't conclude anything that made logical sense. So I've limited all other possibilities, and this is what must be true. Actually, what's that? That's a quote, isn't that? Like, if you eliminate all possibilities, then the remaining conclusion, no matter how improbable, must be true. Yeah. I don't know. That sounds like a quote.
Everything is wrong.
I don't know. Everything can't be wrong.
What if it was like 2 plus 4 equals 6, 8, 9?
Well, then there must be another case that we haven't yet considered. Well, 2 plus 4 is the 6th case would be true. But it,
I say 2.
all right, 2 plus 2. Okay. So then the 4 case, the thing that we didn't list, was still a possibility that I didn't list in my original cases. I didn't consider enough cases. All right, here we go. I don't think we'll do a paragraph proof. Nah. All right, so guys, let's check this out. All right, so I've got some gimmies. Givens. Here we go. So what do I got? Angle XWY, XWY, got it right there, is congruent to angle XY dubs. I got it. All right. And we're assuming that WZ is bigger than YZ. All right. So prove that angle WXZ, where's that one? That's WXZ, this angle, is greater than YXZ. I feel like I'm missing one other piece of information. Oh, all right. Let's see what we can label. Let's work with these two little triangles first. All right. Or actually, no, we can work with the larger. All right. This has got like a bunch of nested triangles in it. Looking at just this yellow triangle, what else do you know is true based off of what's currently labeled in it?
X's.
X, X.
Yeah, because the base angle.
Yeah, XW is going to be congruent to XY. That's what I was looking for. I was like, wait a minute, I need to know that's true. But yeah, I had to look temporarily at that triangle. That's base angles converse. Back. Let's see. I also know that this would be congruent to itself. XZ is congruent to itself. So now I'm no longer thinking of just that isosceles triangle. Why is that congruent to itself? Everybody's favorite. Reflexive. And then, let's see, if I know that this side is bigger than this side, right, that was given to me, then I believe I can say that the measure of angle WXZ is greater than the measure of angle YXZ. Let's see, when I started with the sides and then made a claim about the angles, that was the converse of the Hinge theorem. I don't know, I feel like converse is more of an unusual word. Maybe. It does look like a kite, but it is a poorly designed kite. Like if one of my sons made that, I'd be like, guys, you did a terrible job.
Wow.
You got to raise your standards. How am I going to sell these child-made kites on eBay if this is the quality you're giving me? I'm just kidding. Let's see. Here we go. Example 5. Solving a real-life problem. All right. 2 groups of bikers. All right. You with me, Jack? They leave camp in opposite directions. All right. They travel 2 miles, then change direction and travel 1.2 miles. Group A. Here we go. Group A. All right. Turns 30 degrees. Here we are. All right. So here's Group A. Group A starts due east and then turns 45 degrees north. So 45 degrees north and ends up here after traveling 1.2 miles. What is this angle? 135 degrees, linear pair postulate. Okay. All right. The other group traveled 2 miles, heads west, right? 30 degrees towards south, 1.2 miles. All right. And what would this angle be? 50? 150. Okay. So they travel 2 miles, then 1.2, 2 miles, then 1.2. Question is, who is farther from the camp? Why?
Hinge Theorem.
Because of the Hinge Theorem. All right, because of the Hinge Theorem, Group B will be further away from camp than Group A. Yeah, this is definitely not drawn to scale, I don't think. But that's all right. Well, anyways, there you go, internet friends.
Bye, internet friend.
Bye.
Bye.